dear students, I am Amrita, your chemistry lecturer. Now in this session, we will discuss the analysis of third group basic radical. You already know the group detection of third group basic radical. So let us perform the analysis of third group basic radicals. So third group basic radical, it may contain either aluminium or iron ions. So let us perform the experiment. So in order to do this experiment, you have to take a test tube. Okay. Then to that test tube add small amount of a salt mixture. Okay. Observe carefully. Take a test tube and add slowly the salt mixture to the test tube. Then add few drops of distilled water. You are going to add small amount of distilled water to a test tube. Afterwards, shake a test tube well so that the salt particles are completely dissolved in a distilled water. Okay, so this is called as virginal solution. Now you will prepare a virginal solution. By using this virginal solution, you can determine the third group basic radical. Okay, so take virginal solution in a test tube. To that virginal solution, add dilute hydrochloric acid by using a dropper. To the virginal solution, observe carefully, slowly add dilute hydrochloric acid. Then observe the changes. Here what happens means there is no white precipitate is formed. Hence, it tells us that the first group basic radical is absent. So now you have to pass hydrogen sulfide gas to the same solution. Observe carefully. After passing hydrogen sulfide gas, there is no black precipitate is obtained. Hence, the second group basic radical is absent. Second group basic radical is absent. So then you have to heat the reaction mixture for a while, because to remove the dissolved hydrogen sulfide gas, heat the reaction mixture for few minutes in order to remove the dissolved hydrogen sulfide gas. Afterwards, take solid ammonium chloride. Then add small amount of solid ammonium chloride to a test tube. Observe here. I will take solid ammonium chloride and small amount of solid ammonium chloride is added to a reaction mixture. So observe the reaction. Shake well so that the solid ammonium chloride is completely dissolved. Okay. Then add ammonium hydroxide to the same solution. Okay. Add excess of ammonium hydroxide. So observe the changes. If you add excess of ammonium hydroxide solution, you will get a brown colored precipitate. Observe here, the solution is turned into brown color precipitate. So in a test tube you can clearly notice the brown color precipitate. So this is confirms the or this is tells us that it may contain ferrous or ferric ion may be present in the given salt mixture. Okay, it may contain ferrous or ferric ion in the given salt mixture. Then to the precipitate you have to add sodium hydroxide solution. With the help of dropper, add sodium hydroxide solution. Then it is subjected to a centrifugation. Add small amount of sodium hydroxide solution. Then it is subjected to a centrifugation. After centrifugation, you have to divide the solution mixture into two parts. So one is taken as a residue and another one is taken as a centrifugate. Now I will use the residue. So the residue is taken in a test tube. Observe carefully. Take a residue in a test tube. It is called as part first. In part first you can take residue and add potassium ferrocyanide solution, that is K4FeCN6. With the help of dropper, add potassium ferrocyanide solution. So observe the changes. The solution is turned into blue color. Observe the changes here. The solution is turned into blue color. So this will confirms the Fe3 plus ion may be present in the reaction mixture. So this reaction tells us that this changes, observe that a blue color formation takes place in the test tube. This is clearly indicate the Fe3 plus is confirmed in the solution. So this is the part first. And in part second you have to do the test for aluminium ion. For that you have to take a centrifugate and add solid ammonium chloride. Then heat for a few minutes. Then cool. After few minutes, after cooling, the reaction mixture is turned into gelatinous white precipitate. So this confirms the aluminium ion. So this is about the analysis of third group basic radical. Thanks for watching.